All right, today we're going to be working on section 5.3, the first part, which is properties of trig functions. So we're going to look at these properties right here in order to simplify trig expressions to get our solution. So first thing, let's start with reciprocal properties. We've actually already talked about this before. Sine's reciprocal is cosecant. So this property looks like this. Sine of theta equals 1 over cosecant of theta. Reciprocal means flip it upside down. All right, going over here, cosecant's reciprocal is sine. So we write this as 1 over sine theta. Cosine and secant are reciprocals of each other. So cosine is written 1 over secant theta. And secant's reciprocal is cosine. So this is written 1 over cosine theta. All right, next set of reciprocal functions we have are tangent and cotangent. Tangent's reciprocal is cotangent. So this is 1 over cotangent theta. And cotangent's reciprocal is tangent, so this is 1 over tangent theta. So those are my reciprocal properties. Notice every single one of them has a 1 on the top. All right, now let's look at quotient properties. Quotient property means what can we divide, what two trig functions can we divide to get tangent and cotangent. Now, if you remember back from last week, we talked about on the unit circle, tangent was y over x. Y represents sine and x represents cosine. So tangent here is going to be sine over cosine. All right, next, tangent and cotangent are reciprocal functions, which means basically reciprocal means you just take this fraction and flip it upside down. So if tangent is sine over cosine, then cotangent is going to be the reverse of this or the flip of this, which is cosine over sine. All right, next we have our even and our odd properties. Out of our 6 trig functions, only 2 of these are even functions. Even means it's symmetric with the y-axis. Odd function means it's symmetric with the origin. So my 2 even functions are these 2 right here, cosine and secant. And what an even function does to a trig function is it basically replaces this negative sign with the positive sign. So cosine of negative theta is the same thing as just cosine theta. Secant negative theta is the same thing as just secant of positive theta. Notice these 2 right here, even functions. So when I do the even odd property, the negative sign just goes away. Now the other 4 are odd functions, which means the negative sign's got to stay. Since the negative sign stays, the negative sign has to come out in front. So sine of negative theta is negative sine theta. Notice the negative sign right here beside the angle pulls out to the front. Cosecant of negative theta is negative cosecant theta. Tangent of negative theta is negative tangent theta, and cotangent of negative theta is negative cotangent theta. So those are my even, odd properties. All right, next set of properties, and these are big properties, are my Pythagorean identities. I'm going to go to my notebook paper here to try to show you where these properties come from. All right, the first property we have on our sheet is sine squared plus cosine squared. Anytime you see this, this always equals 1. Sine squared, cosine squared have the same angle. When I add them together with their squares, they equal 1. All right, next property we have down there is sine squared theta. So I'm going to take each of these using my big one up here and basically solving to get my solution here. So sine squared, if I want to take this equation, just rearrange it around. Sine squared, to get it by itself, I'm going to subtract cosine squared. So here I'm going to have 1 minus cosine squared theta. All right, my next trig property we've got is cosine squared. All right, cosine squared theta. Looking at my big property from the start, here's cosine squared. So to get it by itself, I'm just going to subtract sine squared. So this is 1 minus sine squared theta. So basically to get sine squared and cosine squared, I just rearrange those properties around. Now the next one we need to find is cosecant squared on my list. So cosecant squared theta. All right, so I'm going to go back up to this big one, which is sine squared plus cosine squared equals 1. And I'm going to look at this to figure out how can I get cosecant squared. Well, cosecant is 1 over sine. So I need sine to be in the denominator of this fraction over here. So I'm going to take all of these terms and divide every single thing by sine squared theta. Now notice I'm dividing by sine squared since my power in each of those is squared. So right here we've got 1 over sine squared, and there's that 1 over sine squared. That's the same thing as cosecant squared. All right, so looking at this, 1 over sine is cosecant, and the squared just follows it in the answer. All right, so let's come back over here and simplify this side. Sine squared over sine squared just gives me 1, plus cosine squared over sine squared. Since this squared is going to stay, and now we've got to go back and figure out what is cosine over sine. Well, using my quotient property, cosine over sine is actually cotangent. So this is cotangent squared theta. So if I go back up here and plug this in, cosecant squared is 1 plus cotangent squared. All right, next property we have on our list is secant squared theta. Well, to get cosecant squared, we divided by sine squared. So to get secant squared, we're probably going to divide by cosine squared. So let's write our original 1 over. Sine squared plus cosine squared equals 1. And up here, we divided by sine squared. So now what I'm going to do is I'm going to take all of these and divide by cosine squared. And that 1 over cosine is going to give me that secant, which is what we're looking for. Now remember again, we're dividing by squared since each of these have a squared in their problem to begin with. All right, so let's start over here where we wanted that secant. 1 over cosine is the same thing as secant, but now it just happens to be squared since that power is following it. All right, coming back over here. Sine squared over cosine squared. Sine over cosine using my quotient property is tangent. So this is tangent squared theta plus cosine squared over cosine squared. That's the same thing over itself, so that's just going to give me out 1. So secant squared is tangent squared plus 1. Now remember, this is addition. Addition is commutative, so it does not matter which one of these two things I write first. Addition I can do that in, but subtraction I cannot. So I'm going to switch these two things up and write as 1 plus tangent squared, so it looks very similar to my cosecant squared problem. All right, next thing I've got are my two functions, which are tangent squared theta and cotangent squared theta. So basically what I can do is I can use these to help me solve these. So let's start with cotangent squared first, because cotangent squared was in this first one right here. So to get cotangent squared all by itself, I'm going to subtract 1. When I subtract 1, cosecant squared is going to come first. Now remember, this is cotangent squared. So this is cosecant squared theta minus 1. To solve for tangent squared, I'm going to subtract 1 right here. So tangent squared is secant squared theta minus 1. Secant squared theta minus 1. And we've taken this Pythagorean identity and solved for all 6 of these. So let's go back to our chart right here and let's fill in what we just found out. So the first thing, sine squared plus cosine squared gives me 1. Sine squared was 1 minus cosine squared theta. Cosine squared is 1 minus sine squared theta. All right, remember cosecant squared was 1 plus cotangent squared. We could also say cotangent squared plus 1. So 1 plus cotangent squared theta. Secant squared was 1 plus tangent squared theta. Tangent squared was secant squared theta minus 1. And cotangent squared was cosecant squared theta minus 1. So using these Pythagorean identities, now we can help solve problems. All right, so let's look at these 6 examples that we have down here in the bottom. Anytime a problem is squared, I can use these. Anytime it's not squared, I got to resort to going back through all of these other problems that we have right here. All right, so looking at number 1. Number 1, the first thing that I notice is all of my angles are in terms of 20 degrees, which is what I need, the same angle. So I've got tangent of 20 minus sine 20 over cosine 20. So the first thing I'm going to do is look at this right here and try to rewrite this using one of my properties. So this is sine over cosine. What if you notice back up here, sine over cosine is the same thing as tangent. So I'm going to take that same angle and use the same angle as we have right here. So since my angle is 20, this right here just represents tangent. So let's leave the first one alone, tangent 20. And I'm going to subtract, and I'm changing this one over. Sine over cosine is the same thing as tangent. So that's the same thing as tangent 20. Now I simplify. Tangent 20 minus tangent 20, this is the same thing minus itself. So my solution here comes out to be 0. All right, going down to number 2. When I look at number 2, the first thing I notice is I have radians. So the first thing I'm going to do is I'm going to take these radians and change them over to degrees. So let's take pi over 12 and let's multiply it by 180 over pi. Remember, my pi's go away, and we're changing this over into degrees. So basically, I just have 180 divided by 12. So 180 divided by 12 using my calculator gives me out 15. So this basically right here is the same thing as 15 degrees. So I just want to change these to 15th. So this is sine squared 15 plus 1 over secant squared 15. All right, next thing, try to get rid of your fractions if at all possible. So let's look at this right here. 1 over secant squared. Now, since it's squared, I can use Pythagorean properties. But the first thing I'm going to do is use the 1 over secant. And if I go back up here, 1 over secant is the same thing as cosine. But since this is secant squared, this is just going to turn into cosine squared. So now I've got this sine squared 15 plus cosine squared 15. Now, Pythagorean property right here. We've got sine squared plus cosine squared. We have the same angle being 15. So anytime I take sine squared plus cosine squared, add it together, my solution here comes out to be 1 using my property. All right, let's look at number 3. Number 3, we've got sine 80 and cosecant 80. Notice I have the same angle right here, and I'm going to turn one of these two things over. So I'm going to leave sine alone, and I'm going to change cosecant. If I go back up here to cosecant, cosecant is the same thing as 1 over sine. Now, you could change sine. Sine is the same thing as 1 over cosecant, but do not change both. Change one or the other. All right, so I'm going to box this in just to let you know that's the one I'm changing. So this is the sine of 80 times, remember we said cosecant was 1 over sine, so this is 1 over sine 80. And then right here, if I look, I got the same thing in the top and the bottom. Now, if you multiply straight across, you're going to get sine 80 over sine 80. Same thing divided by itself gives me 1. Or since I have 1 in the top and 1 in the bottom, I can cross those two things out, and I'm just left with the answer to be 1. All right, next one we got up is number 4 right here. Number 4, we got 400, and we also have 40. So the first thing I need to do is change this 400 into a coterminal angle, which basically means I want this to be between 0 and 360. So to get a coterminal angle, I'm going to take my angle 400 and just subtract or add 360. So when I subtract 360, this is the same thing as 40. So I've got the cosine of 40 times the secant of 40. Now this is very similar to problem number 3 right here. So I'm going to leave cosine alone, and I'm going to change secant. Secant, right here, remember, is 1 over cosine. So this is cosine 40 times 1 over cosine 40. I've got cosine 40 in top and cosine 40 in the bottom, so those two things go away, and leave me with my answer to be 1. All right, next problem I got is number 5. I've got sine and cosecant, but notice that I have 2 different angles. Another thing that I notice is I have a negative angle. So the first thing I'm going to do is I'm going to take this negative pi over 12 and change it into degrees by multiplying by 180 over pi. So that's going to go away. The next thing I'm going to do is I'm going to take 25 pi over 12 and change it to degrees by multiplying by 180 over pi as well. So my pi's go away. So in this first one, I've got negative 180 divided by 12, so that gives me out negative 15. So this is the sine of negative 15. All right, over here I got cosecant. When I do this one, 25 times 180, all that gets divided by 12, that gives me out 375 degrees. All right, first thing that I notice is this right here is sine of negative 15. I've got 2 different ways to solve this problem right here. First way I can solve this is with my even and odd properties. So if I go back up here, sine of negative theta, the negative sign just scoots out in front. So this right here is the same thing as negative sine of 15 degrees. Now another thing you could do right here is you could take negative 15 if you don't like negative angles, and you could add 360. When you add 360, you get the same thing as 345 degrees. But let's look at this. 375 is too big, so I'm going to change it to a coterminal angle by subtracting 360. When I subtract 360, that gives me 15. Now notice, I have the same angle. If I were to change this one to a coterminal angle, this will be 345. There's nothing I could have done with 345 and 15. I need these to be the same angle. So my odd property was the best thing to use right here. All right, next thing I'm going to look at is changing cosecant. Cosecant is the same thing as 1 over sine. So I'm going to rewrite this. Negative sine 15 times 1 over sine 15. I've got the same thing in the top and in the bottom, so that goes away. So my answer left here is negative 1. So negative 1 on number 5. All right, last one we got right here is number 6. Now my cosine kind of went to the side over here. All right, first thing I'm going to do here is I'm going to take this and use my even and odd properties right here. So I've got the sine of negative 20. Remember, sine is an odd function, so the negative sign comes out in front. So this negative sign is going to scoot out in front, and it's going to give me negative sine 20. All right, on the bottom right here, I've got the cosine of 380. Well, 380 is too big because it's bigger than 360. So I'm going to take 380 and subtract 360, and that gives me out 20. So this is the cosine of 20. Now, notice I have the same angle right here. If I would have taken negative 20 and added 360, I would have gotten out 340. And now my angles don't match up. So I need the same angle here. All right, so we've got plus, let's leave this alone, tangent 20. All right, now, let's use a property to find out what this is. Sine over cosine. Sine over cosine is the same thing as tangent. Remember the negative sign right here. So I've got negative tangent 20 plus tangent 20. And right here we've got the same thing. One's positive, one negative. So it's basically like I'm adding these two things. When I add here, I get out 0. So the first part of section 5.3 was using my properties and getting used to these properties in order to simplify trig functions.